back titration calculation now then. Can you bring the first one, please? Right, so the volume, we had 0.4 moles per decimeter cube sodium hydroxide. And I added, these are all the numbers from my calculation, I added 7.3 cubic centimetres. Now, next button please. So, if I've added 7.3 cubic centimetres of a 0.4 moles per decimeter cube solution, the number of moles I added is 7.3 divided by 1,000 and multiplied by 0.4. That gives me 2.92 times 10 to the minus 3 moles of sodium hydroxide. Now, the equation for this is 2-to-1 ratio. 2 moles of sodium hydroxide react with 1 mole of sulfuric acid. So, when you're doing the calculation, 2 moles react with 1 mole. So if I've got this many moles of sodium hydroxide, the number of moles of sulfuric acid that was in my 25 cubic centimetres was that number divided by 2, which in my case is 1.46 times 10 to the minus 3 moles in that 25 cubic centimetre aliquot that you measured out in your pipette. So you now know how many moles of sulfuric acid there were in 25 cubic centimetres. You added 100 cubic centimetres of sulfuric acid, which means, thank you, that there are that many, 5.84 times 10 to the minus 3 moles. The way I got that, obviously, if there's this many moles in 25, then there is 4 times as many in 100. I simply multiplied it by 4. We then move on. Now, at the start of this, from our burette, we added 100 cubic centimetres. 100 cubic centimetres of 0.1 moles per decimetre cube. Well, that is 0.01 moles. The calculation is there. 100 divided by 1,000 times 0.1. Now, we started off with this much. We finished up with this much. So, when we added the sodium carbonate, it must have reacted with some. And the amount that it's reacted is the starting moles minus the final moles. So it's 0.01 minus 5.84 times 10 to the minus 3 gives us 4.16 times 10 to the minus 3 moles that have been used up. The ratio is 1-to-1. 1 mole of sodium carbonate reacts with 1 mole of sulfuric acid. So therefore, we must have had this many moles of sodium carbonate added in. Which I hope shows, yeah. So it's a 1-to-1 ratio, so I must have added that many moles of sodium carbonate. Well, if I know the number of moles of sodium carbonate, I then use the MR, which is 106. I multiply the two together, and I get 0.44096 grams of sodium carbonate. Hang on a minute, but I added 1.08 grams. You saw that at the start. I added 1.08 grams. So, what percent of my original sodium carbonate was actually sodium carbonate? Well, it's that, the amount that I got, divided by my original amount times by 100. So, if you want to talk about purity, you could say that this sodium carbonate is 40.83% pure. Right? Now, I'll move on to the water of crystallisation experiment, since we're still carrying on filming. So, we said that the original mass was 1.08, but we only had 0.44, approximately 0.44096 grams. What's the rest of it? Well, the rest of it is water. It's water of crystallisation. These calculations we were talking about the other day. So therefore, if that much of it is sodium carbonate, the rest of it, 0.63904 grams, must be water. Now, if we work out the moles of each, we just divide the mass by the MR, and that gives us the moles of sodium carbonate. The mass divided by the MR gives us the moles of water, and then, therefore, we know the ratio of sodium carbonate to water. 4.16 times 10 to the minus 3 is to 0.0355. We divide both sides by 4.16 times 10 to the minus 3, and so we get a ratio of 1 is to 8.5. Right? The bottle says it's 1 to 10. The bottle says it should be sodium carbonate dot 10 H2Os. Where the potential atoms.